Hey y'all, we're on page 8 and we're graphing tangent and cotangent functions. We're going to follow the same format that we used for graphing secant and cosecant. We have the steps that are written out, we have our table, and you'll notice that our table is a little bit longer now because we do need a little bit more of radian values. And then we do have our graph and we're going to fill in some information. So to go ahead and begin with, now remember, tangent is not really on the unit circle exactly, but remember, you can always find tangent by finding sine and dividing it by cos of some specific angle. Now, here's what we're going to do. We're going to go through the table and we're going to fill in everything that we know. So, at 0 radians, our coordinate from the unit circle, remember we're going just like this, so if at 0 radians, my coordinate is at 1, 0. Knowing that tangent is actually sine over cos would be, in this case, 1 over 0, which if I were to really rewrite, is simply 0. So there's your first point for the tangent function. Now, the next one that's actually written out for you, that's already typed up for you, is pi over 2. So if I go to pi over 2, that's up here on the unit circle, that's going to be, the coordinate there is at 0, 1. And if I know tangent is actually sine over cos, that's in this case 1 over 0, which is, hopefully you realize it is actually undefined because you have that 0 at the bottom. And as you know, whenever you have something that's undefined, that's going to give you an asymptote. So keep that in mind. That's going to be a place where we're going to have an asymptote. Okay, the next one that's typed out for you is at pi. Now, pi is over here, and the coordinate there is -1, 0. So sine over cos would be 0 over -1, which is simply 0. Okay, the next one, 3 pi over 2, that's over here at 270 degrees, and the coordinate there is 0, -1. And sine over cos would be -1 over 0, which again, you're right, is undefined. At 2 pi, it actually takes us right back where 0 was, and so that 2, just like 0 is, that 2 will be a value of 0. Okay, so let me go ahead and put down my values that I actually have something for. Okay, and luckily on the left side, it will actually be the same. So let's see, I have a x-intercept at -pi and at -2 pi. So there's that. Now, just like we said earlier, every time you have something that's undefined, at those angles, you actually have your asymptote. So at pi over 2, which is 3 marks away from 0, I have an asymptote. So there is my first one. And here's my second one at 3 pi over 2 down here. And I do know that because I have that point in the middle, at 0, 0, I know that it's going to be the same thing on the left side. So at -pi over 2, I'll have another asymptote. And at -3 pi over 2, I'll have my next asymptote. So there are all of my asymptotes. Now what I need to do, because this still doesn't give me a feel for what the graph is going to look like, and because tangent is completely different, we actually don't know what the graph looks like. So we're going to have to explore more angles. And so I've kept this space for you to write in the next few that we'll explore. And we're just going to take it easy because tangent, as you know, is sine over cos, and so when we work with fractions, it's a bit messy, but let's find some angles where it's going to be very, very easy and very nice to work with. So we're going to use all of the 45-degree angles because hopefully, if you remember, all of the 45-degree angles have the same sine and the same cos value. The only thing that's different is your negative sign or your positive sign based on which quadrant you're in. So let's explore all of the pi over 4 family members. So here's pi over 4, which is in the first quadrant. Now remember, everything in the first quadrant is positive. So square root of 2 over 2 divided by square root of 2 over 2 is simply going to give you 1. How nice, huh? So there's your point at 1. That's why we chose a pi over 4 family member, by the way. It's very clean. Okay, the next one, the next pi over 4 family member is 3 pi over 4, and that's in quadrant 2. So hopefully you know, and let me actually scoot this out a little bit. You know that your cos value is negative, so cos is negative root 2 over 2. Sine is a positive root 2 over 2. But in any case, once you simplify, you'll get a negative 1. The next pi over 4 family member is 5 pi over 4 in the third quadrant, where both cos and sine are negative. And so if you were to throw a negative both for sine and cosine here, you're going to end up with a positive 1. And the last pi over 4 family member is 7 pi over 4, which is in the fourth quadrant, where cos is positive, sine is negative. So you'll have negative root 2 over 2 over positive root 2 over 2, which nonetheless is negative 1. So now we have all of our points, and actually those are sufficient. Those are enough for us to go ahead and graph. Now when we look at the graph, we know that here's 0. We know 3 marks away is pi over 2, so that must mean half of that, so 1.5 marks, should be pi over 4. So at pi over 4, I have a value at 1. I have a point at 1. At 3 pi over 4, which is right over here, I have a point at negative 1. At 5 pi over 4, back to positive 1. 7 pi over 4 is at negative 1. So those are all the points that I have. Now if I connect these dots, here's what your curve will look like. That last one's actually cut off a little bit, but this one is a good one to show. So it's actually going to look just like this, because what's stopping you is that asymptote. Remember, you can't go past it, so you have no choice but to go up from there. And down here, no choice but to go down. Now here, I have these points, no big deal. And because you know these are repetitive, you can actually then say that looking at the pattern, then I know there should be a point here at negative pi over 4. If I were to go in the negative direction with the negative angles, negative pi over 4 would give me negative 1. So there we go. If I just follow the pattern, I can go ahead and continue over. There you go. So now our general equation for these tangent functions, we'll just go ahead and say is tangent of theta. Now again, the nice thing is that all of your transformations, A, B, C, and D, they all work the same way, just like you've been doing, which is really nice. Now, the period is what changes for tangent and cotangent. Remember, the definition of a period is the amount of radians it takes to finish one complete pattern. If you really take a look at this, one curve is one pattern, because then it just repeats. It just repeats. So it takes now just pi units for one period to finish for tangent. Just pi. Okay? Now our domain, remember, is just like we did for secant and cosecant, is going to be based on where your asymptotes are. So let me skip the domain, let me skip the range for now. Let me come down to equation of asymptotes. So just like we did for secant and cosecant, where's my first non-negative asymptote? So it's at pi over 2, and the next one is pi units away. So there you go. It's in the same format as it was for secant and cosecant, which is nice. So now according to that, and according to your graph, where are your two specific? Just give me any two specific asymptotes. You have a variety of options that you can choose from. I'm just going to give the first two positives. So I'm going to say pi over 2 and 3 pi over 2 are my first two that I see. There's that. Now using my equation for an asymptote, let me go back and write down my domain. Now remember, the domain is not what the, the domain is not where the asymptotes are. So I'm going to say x does not equal every location of the asymptote. And there you go, just like for secant and cosecant. Now my range, if you really take a look at it, from the bottom to the top, there's actually nothing vertically that's limiting the range. Nothing at all. So it's actually all real numbers for the range, which is pretty nice. And there you have your tangent function, tangent curve, done. Now we're going to do the same thing for cotangent. So we're going to go ahead and fill in the table. And the good thing about this is we have, all we have to do actually is take a look at your tangent table and simply take the reciprocals of the values that you've already found. Take the reciprocals of the values that you've already found. And actually, it should have given you an extra spot to put this in. This cotan of theta should have been up here. Let me just extend the table. So if I take a look at my first value, or my first angle, which is 0, for tangent, tangent is actually 0 at 0. Now if I take the reciprocal of 0, which is really written as 0 over 1, if I take the reciprocal of that, it becomes 1 over 0. Now hopefully that becomes an alarm in your head, and you're right, that's actually undefined. So now here's the thing. Every time where tangent had a value of 0, cotangent will actually have an undefined value there. Every single time. So let me see where else tangent was 0. Okay, here at pi. So then if I take a look at pi, which was 0 over negative 1, which gave me 0 for tangent, if I take the reciprocal of that, negative 1 over 0, there you go, you have 0 at the bottom, again, undefined. And the last place we'll have an undefined value is at 2 pi, because tangent was 0 at 2 pi, the reciprocal of that is undefined, just like we said. And so because that's true, that wherever tangent is 0, cotangent is undefined, vice versa is also true. Where tangent was undefined, cotangent will be 0. So at pi over 2, cotan is 0. At 3 pi over 2, cotangent is also 0. Okay? So now let's go ahead and put down our asymptotes. Every time we have an undefined value now will be a asymptote for your cotangent function. So here at 0 we have one. We have one at pi, at 2 pi, and of course the negatives of those as well, at negative pi and at negative 2 pi. Okay, I already know some of my points. At pi over 2, I have a point at 0. At 3 pi over 2, I have a point at 0. Same thing for the negatives. At negative pi over 2, I have 0. And at negative 3 pi over 2, also 0. Now, just like we did for tangent, we're going to work with the pi over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now if I take the reciprocals, here's the nice part, if I take the reciprocals of those values, they actually remain. Okay, they remain the same. So reciprocal of 1 is still 1. The reciprocal of negative 1, still negative 1. Reciprocal of 1 is 1. Reciprocal of negative 1, negative 1. So now let me graph those other points that I just put down. Pi over 4 is at 1. 3 pi over 4, negative 1. 5 pi over 4, 1. 7 pi over 4. Oop, I have this point a little bit off. Oops. 7 pi over 4 is at negative 1. So if you take a look at that, it's actually a reflection of tangent. It's a horizontal reflection almost of the shape of your tangent function. So if I now go ahead and connect those points, you might be able to see it a little bit better. Just like that. And I'm going to repeat the same thing on the left side, just repeat that pattern. And there you go, your cotangent function. So my general equation is y equals cotan of theta, and again, a, b, c, d values remain the same. And just like tangent, the period of a cotan function, again, the time it takes to repeat, to complete one pattern before it starts repeating is again 1 pi. To write the domain, I'm going to do the asymptotes first. So I want the first non-negative asymptote, which is at 0. And after that, it's at every pi unit, so pi times k. two specific asymptotes, again, you have several options here. I'm going to choose 0 and pi because those are my first two positives. That's all what I'll choose. My domain is solely based on my asymptotes, and I'm going to say x does not equal 0 plus or minus pi k. And just like for tangent, range here too for cotangent is also our real numbers because you have no limits vertically. And there you go. Tangent and cotangent graphs are done.